Hello everyone, so just now we discussed the spanning tree. So now let's see the other thing here. If you see here, we have the switch priority. Already just now we discussed, we have the switch priority is 32768. In all Cisco switch by default we will have the priority and they are going to add the VLAN number. Just now we discussed that one. So if you want, I will show you how we can check that one. We will write the show spanning tree, and if you see, this is the priority 32679. Actually this is a 32768 plus VLAN. Example, maybe you have confusion. Let me do one more thing. I will go here, I will write VLAN 10. Okay, I will give name as a IT, and then we will check here. I will write spanning tree. Okay, when I click now spanning tree, we have two instances running now. One is for VLAN 1, one is for VLAN 10. We created VLAN 10, right? Just now we created VLAN 10 here. So now here only it is showing VLAN 1 only. It is not showing VLAN 10 because we did not put any PC in that one. In which switch I created? I created in the switch 1. Okay, I created in the switch 1, so we will have the two instant, means two table we will have. One table for the VLAN 1 and we should have one more table for the VLAN 10. It is not coming because we need to put some interface in the VLAN 10, then it will come, or we need to create the trunk here, so it will come there. So I will create the trunk as this two interface E0 by 0, E0 by 1, because the link which is connecting between two switch, always we make that one as a trunk to carry the multiple VLAN. So in the switch 1, I will go in the global configuration mode. I will write interface range. Why I am using range? Because I want to select the multiple interface same time. Multiple interface I want to select. I want to select this interface and this interface. So I will select with the range, with the command range. So now I will write interface range, then E0 by 0 dash 1. This way I selected. I given E0 by 0 and last number, what is last number is 1. So I given the E0 by 0 dash 1. With this command I selected the multiple interface. Now we can write switch port trunk encapsulation dot 1q. Then we will write switch port mode trunk. So this way I created the trunk. Now we will have the two table. STP will have the two table. First let me check show interface trunk. It is having the trunk. Okay, we are using 802.1q. If you see, we have two interface as a trunk. This interface as a trunk and this interface as a trunk, and both interface is allowing the all VLAN. Now we have the VLAN 1 and VLAN 10 in these two interface. Now we can write show spanning tree. I will press enter. Now we will have two table. If you see, this is a table for the VLAN 1 instance, and if you see here VLAN 10 here. Okay, this is a VLAN 10. Before we don't have this one. Now it is coming. Why it is before? Why we don't have? Because we need to put one interface in that VLAN to get that detail. Or if you want to, like if I want to get that detail, I need to put one PC here and I need to put this interface in that VLAN, example VLAN 10. But I don't want to do that one. Then other option, I will create this as a trunk, then automatically multiple VLAN allow here. So spanning tree start working for the other VLAN also. Else spanning tree will think this VLAN is not connected, so I will not run. So when spanning tree is running, our CPU is utilizing. If you have 100 VLAN, 100 separate spanning tree is going to work. Means here if we check here, we are having the spanning tree 1. This is the spanning tree is working for the VLAN 1, and this is the spanning tree working for the VLAN 10. If you create like VLAN 10, 20, 30, 40, your CPU will run each and every instant. Means every time they will do the calculation. This one will have separate calculation, this one will have separate calculation. So we have multiple calculation, multiple table, and we can have this VLAN. For this VLAN, maybe this switch is a root bridge. For the other VLAN, maybe we can create other switch as a root switch. We can play like this also. Example, we can say for VLAN 10 traffic, this guy will be king. But for the VLAN 20 traffic, this guy will be king. and VLAN 30 traffic, this guy will be king. We can do like this, because whenever we are sending the traffic, if we did not done this one, all switch traffic will come here. Example, if this guy is king, for all the VLANs, all traffic should come to the king. The rule is here, the one rule what we have here, whatever frame is going in the network, that frame need to pass through king switch. If I am sending any traffic to this PC also, this will not go like this way. This will go through king switch. So this switch is having lot of load. For VLAN 10 also going traffic here, VLAN 20 also going traffic here, VLAN 30 also going traffic here. So for that purpose we can do other thing. We can create this king for VLAN 10, this is a king for VLAN 20, this is a king for VLAN 30. If we do this way, we will share the load. So CPU will not utilize more here. Means it will utilize to do the calculation for VLAN 10, VLAN 20, VLAN 30. But it will load the traffic. VLAN 10 traffic will go through this one. If we have VLAN 30, it will go through like this one. Anyhow, we will see, depending upon the company, maybe some company they will not do like this way, they will keep only one switch as a king switch. We will see that one, no issue. And if you want here, let me show you here, same thing. Here what I will do, I will create one more VLAN here, okay. I will write here config T, I will create VLAN 10 here. And I will exit, and I will write here show spanning tree VLAN 1. If I want to check for VLAN 1, so see here what I am saying here, I am checking the spanning tree table for VLAN 1. If I want to check the spanning tree table for the VLAN 10, I can do here like this. I will still it is not running here. If you see here, it is, we are getting that VLAN 10 is not there, because we did not put this interface in VLAN 10, or we did not created this one as a trunk. If I create this one as a trunk, we will have the VLAN 10 also, or we need to put one interface in the VLAN 10, because whenever we have the spanning tree, whenever whenever calculation, whenever CPU is doing the calculation for the, what we can say, for the spanning tree, it will hit the CPU, so CPU is going to use. So here switch is checking, I don't have any interface in that VLAN, so then why I should do calculation for this VLAN? That's why he is not doing any calculation. So if we want to ask the switch to perform this table separately, then we need to put this interface in that VLAN or create the trunk port. When we create the trunk port, he will say all VLAN is going through this trunk port, so I need to do the calculation for all the VLAN. So now I will create the trunk port. Let me make as a trunk. I will say fast Ethernet 0 by 1, fast Ethernet 0 by 2. We will create as a trunk. I will go interface range, then we will give fast Ethernet 0 by 1 dash 2. This is basic command. Then we will write switch port. We are using the layer 2 switch, so directly we can make as a trunk like this. I make as a trunk. Now I want to check. I will write show interface trunk. So now I have two interface as a trunk. So now we can check. What we can check? We can write show spanning tree VLAN 10. Before it is not showing, but now it is start showing that one. Okay, if you see here, what we can say, this bridge is a root bridge. Okay, this is a switch 2, and for the VLAN 10 also this guy is a root bridge. And if you check for show show spanning tree VLAN 1, for this guy also this switch is a root bridge. Okay, so all VLAN, this guy is a root bridge. We can play that one, we can change that one also. Like we can go here config T, and let me create VLAN 10 in this switch also. I will go in this switch, I will create VLAN 10 here also. Example, I will create here config T, I will say here VLAN 10. I created VLAN 10 here. Okay, I will write here show spanning tree VLAN 10. I have here, this guy is not a root bridge. Okay, this guy is not a root bridge. So what I will do, I will go here, I will write spanning tree VLAN 10. Okay, and I am pressing question mark, and then I will say priority, and then I will say question mark, and he is asking what priority we need to give. I need to give, I am trying to make this guy, this switch 1 as a king for the VLAN 10. Okay, what I am saying here, to do the load sharing, we can play with this one. We can say for the VLAN 1 this guy will be king, for VLAN 10 this guy will be king. We can do this one manually. By default all the VLAN king is this guy only king for all the VLAN, but we can change also. So how we can change? We can go here, we can write spanning tree, then for which VLAN you want to do the configuration, write that VLAN number, and what you want to do, you can write here the priority, and you can change the priority. As you know, which one is having low priority, that guy is going to become as a king. So you should remember this is a priority. Okay, the king priority is this. If you reduce this priority, if you make this switch priority less than this one, this guy is going to become as a king. So what I will do, if I don't know what shall I write the number, I will write here example what where is that command, or let me write again. I will write here spanning tree VLAN 10 priority, and I will press example, I will press any random number, example I will press 5. I press unwantedly 5 because I want to check the range, because there is a range. We cannot assign priority as any number. We cannot assign priority as any number. There is a multiple range. We need to select the number. We can give 0, we can give 4096, we can give 8192. This numbers is there. We can give any number from this. Okay, we cannot give any random number. To get this information, I put this 5 here. So automatically they are showing us, they are saying that if you want to increase the priority, you should multiply with this one, or you can select the number from here, any one number from here. So what I will do here, I will select the number. I know what is a king switch priority. We already know king switch priority. If we don't know, we can go here, we can check this is a king switch priority. So I need to put the priority less than this one, 32778. So what I will do, I will go here, I will check here 3278. We are saying 32768. This one we have, right? This one we have. So I will take this priority. This is the less than that one. So I will copy this, and then we will put the same command, and instead of 5 I will put this here, and I will press enter. Okay, I will press enter, and now they will do again election, and we can write show spanning tree. I will press here. If you see here this one, let me put big screen. I put show spanning tree. So what we are getting, we are getting one table. This is a table for VLAN 1. Okay, we have two instant, 2 time VLAN is running here. One is for VLAN 1, 2 time is STP is working here. If you have 100 VLAN from 1 to 100, STP will work for VLAN 1, VLAN 2, VLAN 3 till VLAN 100. All CPU is going to utilize for this calculation. To overcome this issue, we are going to use MST, multiple spanning tree. We are going to discuss that one also. Now just see here, we have 2 VLAN, VLAN 1, and we have another VLAN, that is VLAN 10. We have 2 VLAN here in our switch. So we have 2 tables. Just I put show spanning tree, it will show VLAN 1 information. After that it will show VLAN 10. And if you see for VLAN 1 what we are getting information, he is saying this is a priority 32769 for VLAN 1, and this guy is not a king. Okay, this is a root ID. So here we don't have anything written, this guy is a king. So we can say switch 1 is not a king for VLAN 1. And if you want to compare, you can compare this MAC address and this MAC address here. Both are not same. Breach means this guy, switch 2, switch 1. So we can say for the VLAN 1, this switch is not a king. Okay, switch 1 is for VLAN 1 is not a king. But now if you see here, this is a VLAN 10, and if you see here, just now we make priority change. So what we are getting, 28682. This is a priority, and this is a MAC address, and saying that this is a king switch. This bridge is a root bridge. This is a king switch. And if you see this MAC address is same. So this switch 1, switch 1 for VLAN 10 is a king switch. Okay, So all the traffic, whatever is going for the VLAN 10 will pass through switch 1. But whatever traffic is going for the switch 1, he will pass through other switch, whoever is having the king switch. In our scenario, I think switch 3 is a king for VLAN 1. Okay, so how we change? Let me show you that one. What I done, just I type here spanning tree VLAN, and for which VLAN I want to do this configuration, that VLAN number, and what I need to do, I can increase the priority or decrease the priority. So I don't know the priority, then I put the question mark, then they are giving, I can put from here to here, but they are saying we should increase this 4096, means we should multiply 4096. Or if you want in more detail, then you put any random number here. So bridge will show you bridge priority must be increment of 4096. So you will multiply 0 with this number, it will be 0, and then you will multiply 1 with this number. If you multiply 2 with this number, if you multiply 3 with, like this, you have the sequence, but no need to remember this one, just put any number, you will get this sequence. After that, check the our bridge king switch priority, and check here in the range who is having the less than that one. You can put that number here. So this guy will become as a king for VLAN 10. And if you go in the other switch also, this is a king switch, I think this guy is king, right? This is a king, let me check, this is the king. Okay, before this guy switch 2 is king for all the VLAN. Now if I check here, it will not king for all the VLAN. I will write here spanning tree, and if I check like this, or let me write like this, if you see, this guy is only for the king for which VLAN? VLAN 1. This is a VLAN 1 till here to here, and this guy is king. This is a king for VLAN 1. But if you see VLAN 10, this guy is not king. So we can do like this way also. Okay, so we can change the priority also, and we can make the other guy to become as a VLAN 10 root bridge for other VLAN. So this is a priority, we just change and we check. And here how STP is working, first they will select the king switch root bridge. STP will select the root bridge, and they will select the root port, they will select the designated port, non-designated port. So first we will see how they will select the root port. Already we discussed, I wrote the procedure here. They will check the bridge ID with the lower bridge ID. They will check the bridge, they will check the switch with the lowest bridge ID. Bridge ID is nothing but priority plus MAC address. All guys is having the same priority, so they will check the MAC address. Whoever is having the low MAC address, that guy is going to become as a root bridge, is nothing but king switch. Already we discussed. Okay, here I wrote the procedure for your reference purpose. So what I am saying, any switch can become as a king switch depending upon his bridge ID. Whoever is having the low bridge ID, that guy is going to become as a king switch. How he is going to become as a king switch? With low bridge ID. What is bridge ID? Bridge ID is nothing but priority plus MAC address. Priority means the switch priority. By default, all Cisco switch is having this priority. So we will ignore this one. We will go for the MAC address. Whoever is having the low MAC address, that guy is going to become as a king switch. And this is the default priority plus VLAN number. If you see, just now we created the VLAN 10 here, right? So let me check here where I done. This is a VLAN 10. Okay, so if you see, this is a priority 2778. Actually this is a priority 32768 plus 10. When we add plus 10, this become here this one. So what we are saying, if you want to get the priority, the original priority plus VLAN number, this is a VLAN number, so it will add and it will give you the priority. So we have this one, and then we will check the MAC address, and whoever is having the low MAC address, that guy is going to become as a king. So but how switch are learning this one? How switch are know who is having which MAC address, which guy is having which priority? How switch will learn? Switch will learn with the BPDU. All switch exchange the information, that is called BPDU. Switch is going to exchange the information through BPDU. BPDU stands for Bridge Protocol Data Unit. Switch send the BPDU every 2 seconds. This is also interview question, you need to remember. Switch is going to send the BPDU every 2 seconds. And BPDU is nothing but Bridge Protocol Data Unit. What information we will have inside the BPDU? We will have the priority, MAC address, port cost. We are going to check this later. But now just remember, BPDU is also a small frame which is having the information. Let me check if I can capture here. This is a switch, right? I will go here, I will click this one, start capturing. Okay, just press this one. This is a Wiresharp. We can say this is a packet analyzer. We can say this is a tool which we use to analyze the network traffic. We can say network analyzer also, this one. Okay, so I will go here, I will write here STP. Okay, and I will click this one and I will search here this one. So if you see, this is a STP packets we are getting here. Okay, this is a STP packet. So if I take any packet, if I want to open any packet, I can open here. Let me move this up. And if I see, you have the STP spanning tree protocol. This is a BPDU. Okay, this is a BPDU. If you want to study this one, we can study here. What we are saying, this is the BPDU, and this BPDU type is configuration BPDU. BPDU also we have 3 types. BPDU we have 3 types. We are going to discuss this one in the coming classes. BPDU is having 3 types. One is configuration BPDU, one is topology change notification BPDU, one is acknowledgement BPDU. Means one BPDU is sending the configuration, means our priority, MAC address, everything they are exchanging in the configuration BPDU. And in the network, if any port go down, if any new port added, then we will have the topology change notification, one frame saying that there is something change in the topology, that is known as topology change notification BPDU. We have another BPDU. Example, if switch 1 sent to the switch 2 saying that we have topology change notification. Example I have like this. Okay, this guy will send here, this guy will send in the BPDU configuration BPDU, they will do the election. But later if I add one more link here, I add one more switch here, example like this way, if I add one more switch like this way, then what this switch will send topology change notification here. He will send to this guy, there is something changed, some topology is changed, someone is connected here. So this guy will reply and he will acknowledge saying that I acknowledge that one. Again they will exchange the configuration BPDU with this new link. So they will do again election and they will perform the again king election. So now what we get here, if you see here, we have here BPDU is a configuration BPDU, and here is a flags in that one. And after that, here if you see topology change acknowledgement, no one is acknowledged. Topology change, no one is say anything change because we did not change anything. And what information we have in the BPDU? We have the route identifier. In that one we have the priority 32768, this is a priority, and we have the, this is a MAC address we have. And if you see path cost is 0 and the bridge identifier, we have the priority. And if you see the bridge priority, that is bridge priority, and the system ID, that is a for VLAN 1. And what else we have? We have the maximum edge time, that is a 20 second, hello time is 2 seconds, forward delay is 15 seconds. So this all information is present in the BPDU. And which BPDU? This one is a configuration BPDU. And now if we play here, like example, this is our this topology, right? And which packet I am capturing? I am capturing in between this 2 1. Okay, in this 2 switch. So if I make any switch down, any interface down, we will have topology change notification also, we can observe. So I will go in the switch 3, I will say E0 by 0. I will go in the switch 3. What I am doing here, what I want to explain here, I am saying here, we are capturing the traffic here. Okay, they are sending the BPDU. Okay, they are sending the BPDU, they are exchanging the information. And what information they are exchanging, we already discussed, we have here, but in detail we are going to discuss. Maybe you are confused here, you will say what is this age, maximum age, and what is this what we can say hello time, what is this forward delay. We are going to discuss this later. But now you have the idea, we have this information in the BPDU. And if you see, every 2 seconds they are sending the BPDU, and they are using the MAC address, this MAC address they are using. Okay, every 2 seconds they are sending the BPDU. These guys are sending every 2 seconds. And if you see, all the BPDU is having the configuration BPDU, this configuration BPDU they are sending. Now I want to do something here, like we are saying, whenever we have anything change in the network, they will send the topology change notification BPDU. So we need to observe that one. So for that purpose, what I will do, I will make this interface done. If I make this interface done, or I add one more interface here, if I do something here, we will have the change in the topology. So this guy will send here topology change notification. So let me add one more switch. Better I will add one more switch here. Let me take one switch here, this one, just to show you topology change notification. I will keep here, and I will go here, I will add from here to here, any interface I will add, and I will make this switch on. Okay, I will make this switch on, and here we will observe, we will get topology change notification here. If you see, we will have in black color something saying that TCN, topology change notification, we will have here. It will take some time, it will not come immediately, because they have some states, they are going in the listening, learning, forwarding, so it will take some time, but no issue. Later we are going to discuss what is listening, what is learning. Now just observe, we will have that topology change notification. He is not doing any, still we did not get, we should get here. Yeah, if you see here, topology change notification, this one is sending. Okay, and if I select this one, what is there in this one, we can, and we will have one more notification acknowledgement also we will have. Okay, if you see here, topology change notification we receive, the other guy will acknowledge also, the other guy will acknowledge here topology change notification. First of all, let's see this one. I selected this one. Okay, and if I go here, what we are getting here in the STP, here we are having the BPDU, we don't have any information. See here, when we have the topology change notification, that is TCN, when we have the BPDU TCN, BPDU, when we have BPDU TCN, in that one we will not have any information, just we have the notification saying that something is changed in our topology, that's all. If you see, we don't have anything here. If I open already here topology, this one I open already. What you have here, just we are having, it is a spanning tree, and we have here version, which version it is running, and here we are getting that only notification, no information. Okay, then we check the other thing. After that we have the configuration BPDU. If you see, this is the configuration BPDU, and here they are acknowledging also in that one. Okay, first one, someone sent something change in the topology, the other guy is replying, okay, I acknowledge that one. If you see, topology change acknowledgement, this guy is acknowledging, he is saying okay, I received that, you are saying that topology change. After that they will send the configuration again, and they will do the election. Depending upon that election, they will change. Maybe sometime we need to change king, maybe someone increase the priority, maybe someone decrease the priority. So depending upon the priority increase, priority decrease, we need to make new guy as a king. If anyone having the low priority, we can say that other guy is a king. So all the information they will exchange again, whatever the bridge ID, whatever the MAC address, all information they will exchange, and after that they will do the election. So what we are saying, BPDU is a frame which is having the information. Every 2 seconds they are sending that information. After that, what we can say, they will select who will be the king. When we change anything in this topology, we have the topology change notification, and other guy is saying that yes, this guy is saying there is a change in the topology. This guy is saying yes, I receive and I am acknowledging that topology change notification you send me, I received that one. After that they will again exchange the information, again they will have the election. and one guy will become as a king, depending upon the same thing. What we have criteria to become as a king? Priority. All guys having same priority, then they will check again the MAC address, and then if this guy is having the low MAC address, maybe this guy will become as a king, and this guy will not, he will leave his position. Let me check what is the priority for the, what is the MAC address for this guy. Let me take the console. Maybe this guy become as a king, we don't know. Maybe if he is having the low MAC address, he can become as a king also. Okay, so if you see here, this guy is not become as a king because he is having this is a switch 4. What is the address? Okay, see, his address is 400, so this guy will not become as a king. But if this address is lower than the king, this one, if you have 100 here, maybe if you have 50 here, here if you have in the king, if you have 100, but here if you have 50, then this guy, this switch 4 will become as a king. All traffic need to pass through switch 4, but here it did not change because it is having the high MAC address. Okay, so now with this one, what we understand here? We have the BPDU, and with the BPDU they are going to do the election. Okay, so till here, and how we will check? We will write show spanning tree. Same thing what we discussed, I put here. After that we are going to see non-root bridge. Non-root bridge means one guy will become as a bridge, all other guy will be non-root bridge, and what we can say, non-root bridge will receive the update from the root bridge, and they update the STP database, because whoever become as a king switch, he is going to send the update, another guy will receive the update and they will update the database. After that we have the port priority. So let me start.